Good. So thank you very much for the kind invitation to speak at the Microplastics in our webinar. When I was invited, I was asked to speak about plastics as a chemical problem, or are plastics a chemical problem? So let's start off with what we know to be a problem for plastics, which is plastic pollution. Of course, this has inspired many different approaches to deal with the problem, one of them being a focus on alternatives to single-use plastics, which are the most widely found plastic pollutant item on beaches worldwide, but also reusable plastics, for example. And the big question that I want to address today in my presentation, very big question actually, is how do chemicals in plastic packaging affect human health and the environment? And also, are the alternatives to single-use plastic packaging safe in terms of their chemical composition? So let's take a quick look at the role of plastic packaging and especially food packaging. So as you can see here, these are the most recent data from Plastics Europe. Packaging is the biggest use of plastic global production, and more than half, it's very difficult with these numbers, but I'd say about 55% of packaging goes into food packaging. And so that makes about 22% of the total plastic production going into plastic food packaging. So if we look at food, most of the foods that we consume are packaged, or the majority at least. This is from a recent study from Portugal, but I'm sure the data would be similar in various countries across the world. And if you look at the types of packaging that are used to package foodstuffs, this includes food and beverages. So when I talk about food, I mean both solid and liquid. If you look at the types of food packaging, obviously here the big chunk of the pie is plastics. And then you see a couple of other different materials that come in contact with food and that actually have a direct plastic layer in direct food contact. So these multi-layer, multi-materials here are beverage cartons, and they have a direct, usually polyethylene or polypropylene layer in direct contact with food, so that you have a direct food contact layer. The same for many metals, for example. Metal cans, food and beverage cans, typically have a synthetic layer on the inside, a coating. Some of them don't, but those are the exceptions, like white fruit and so on. But tomatoes or beer, fizzy drinks and so on, they all have this coating to prevent damage to the metal. So here we can then say most food packaging is plastic, or it has a plastic-like synthetic material in direct contact with the foodstuff. So plastic food packaging and plastic food contact materials are very, very important when it comes to food packaging overall. So let's take a quick look at the key terms, because I'll be throwing these around quite a lot. The packaging, here your finished yogurt cup in this example. This is what correctly would be called a food contact article. It's a finished product, it's a finished article. It consists of various different food contact materials. So in this example, you maybe have a plastic cup, you have an aluminum lid, you have a coating on the aluminum, you have adhesives that glue the lid to the plastic cup, and you have printing inks on the plastic and on the aluminum. And maybe you have more materials. So these are food contact materials. Together, they make up the food contact article. Just a word of caution, if you're new in this field, oftentimes these two terms, food contact article, food contact material, are used interchangeably. So people sometimes get a bit sloppy with the terms, including me, but this is really what we should be using. Material, if we're talking about the material, and article, if we're talking about the food packaging in this case. There's also, of course, other types of food contact articles. When you think of tableware, kitchenware, processing equipment, storage tanks, and so on. All of these materials are made up of what we call food contact chemicals. So this is not a legal term. We coined it at the Food Packaging Forum just to facilitate the discussion. What do we mean? We mean really the chemical entities, what makes up these different materials that consist of different chemicals. So you have chemicals that are intentionally added, the monomers, additives, pigments, catalysts, and so on. But then we also have impurities and reaction byproducts and breakdown products of the additives and so on. All of these we call food contact chemicals, regardless of whether they're there to fulfill a function or not. Why do we care about these chemicals? Well, because there's a transfer, a partitioning of these chemicals from the food contact article into foodstuff. The technical term for this is migration. And in this illustration here, you can see the little red dots in the bottle here are small molecules. So for example, your monomer that hasn't reacted, small oligomers, additives or impurities, they can transfer from your food contact article, your food packaging, into food, but also chemicals from outside. For example, in the environment, ambient contaminants or also adhesives or printing inks that are outside on your food contact article, they can go into the packaging or even directly into the foodstuff, depending on the material properties of your food contact article. By the same token, chemicals in your foodstuff can partition into your food packaging. So this could be the case, for example, for vitamin C or nutrients, other types of nutrients, or flavor molecules. But of course, also, this is an issue when you think about recycling and people use food contact articles, food packaging, to store non-food grade chemicals in there. The materials, plastic, for example, could suck up those chemicals, and then they are in the plastic, and like that, they could get into the recycling stream. So this is a very serious concern. So what are the aspects that determine the level of migration? There are a few. Heat obviously plays a big role. If you have higher temperatures, you get faster migration, you get higher levels of the steady state. Time plays a big role. Longer storage time leads to more migration. The chemistry of the food, the chemistry of the packaging, of course, very, very important. Packaging size, maybe that's less intuitive. If you have, for example, a beverage carton of orange juice and you have 1 liter, then you have a certain surface to volume ratio. So your surface of the packaging to the volume of food has a fixed ratio. And then you decrease the serving size. You go from 1 liter to 250 milliliters, for example. Then your surface to volume ratio increases. So you proportionally have more packaging surface to volume of food. And because the chemicals migrate from the surface of your packaging into the food, you get proportionally higher migration in smaller serving sizes, in smaller size packaging. And then, of course, last but not least, this is the most important aspect, really, the levels of your chemical in your food contact article will determine what levels will migrate into your food. Now, what are the chemicals that are used to make food contact materials and articles? This is a recent study that we published actually just, I think 2 or 3 weeks ago. My colleagues at Food Packaging Forum, Xenia Gros and others, put together this database of intentionally used chemicals by reviewing global inventories of industry lists, but also government lists. And this is for all types of food contact articles and materials. It's not just plastic. This list contains 12,285 chemicals in total that, to our best knowledge, are intentionally used to make all the different kinds of food contact materials and articles worldwide. Obviously, if you go to different geographic locations, you may have less chemicals that are authorized or being used, but this is this kind of gives the universe of food contact chemicals, as we say. And based on the available toxicity data, we then prepared a ranking and came up with a prioritization for 608 most hazardous food contact chemicals that we would recommend to not continue using in food contact materials. And this prioritization is based on certain hazard properties that these chemicals have, ranging from more human health concerns, carcinogenicity, mutagenicity, endocrine disruption, to the environmental aspects, aquatic toxicity, persistent accumulative. We also published already almost 2 years ago a database of hazardous chemicals or chemicals used to make plastic packaging. So this zooms in on plastic food packaging, but also non-food grade plastic packaging. And this database is shorter, smaller. It's about 4,200 substances. Again, we did the same exercise, compiling the toxicological data where available, ranking the chemicals based on their toxicological properties, and then came up with this list of 148 most hazardous substances for both human and environmental health. So very much the same exercise, but here the scope was a little bit different and maybe of more interest actually also for people working on plastic specifically. Okay, so this is a look at the intentionally used chemicals. So these can be monomers, these can be additives, processing aids, and so on. But what about the migration? Coming back again to the migration, I told you before that we define food contact chemicals as all the chemicals that can be present in any food contact article. And that includes chemicals that are not intentionally added. So these are the chemicals that we call NIAS, non-intentionally added substances. And these would not appear on our inventories of intentionally added substances, obviously. They're non-intentionally added. But of course, they are also relevant for migration. They can also migrate from food packaging, for example, into food. And I want to show you a slide now from Dr. Gregor McCombie, who's an enforcement officer here in the canton of Zurich in Switzerland, where I live. And he estimates that potentially migrating substances, so this includes the intentionally added and the non-intentionally added substances, are up to 100,000 different chemicals. So this, of course, is a huge number. And if we break it down, consists of what I mentioned before, what he calls here the listed substances. So these are around 12,000, as we have in our food contact chemicals database. Then in Europe, this is interesting, European Union regulation lists chemicals only, well, plus minus, but mostly only for use in food contact plastics. So the specifically regulated substances in Europe, most of them are authorized for use in food contact plastic. And this list is about 1,000 chemicals. And then the last little square here, again, a factor 10 down, about 100, maybe even less, of those chemicals are actually effectively controlled. That means when the enforcement officers do their job, go to supermarkets, pull samples off the shelves and analyze them, they mostly look at 100 or less chemicals. So this just to give you an overview of what the situation is. There's a big gap between potential migration, human exposure, environmental exposure, and what's actually being controlled. Now, you may say that, okay, there's lots of different chemicals used to make food packaging, but people have been eating packaged foods for at least 40 years. We don't see people dropping dead on the streets. So, you know, I mean, it's got to be safe, right? The regulator has to be taking some kind of measures. And yes, of course, again, focusing on Europe here, what's the European legal situation? The legal definition of food contact material safety in Europe is laid out in the framework regulation for food contact materials and articles, and it states that materials and articles shall be manufactured so that under normal or foreseeable conditions of use, they do not transfer their constituents to food in quantities which could endanger human health. So there you go. Then obviously take into account that this phenomenon of migration, chemical partitioning, does occur. But they say there are levels. There's a threshold, basically, below which you can consider that chemicals that migrate are safe. Now, one of the things that I didn't mention before, when I showed you the slide by Gregor McCombie and his potentially 100,000 chemicals migrating, is that on the one hand, we do know more or less which chemicals are being used to make food contact materials. But on the other hand, all the non-intentionally added substances, impurities, reaction breakdown products, and so on, often are not known. And those of you who have tried to identify the chemical composition of plastics, any type of plastic, probably know this very well. There are many, many different chemicals in there, and most of them actually are unknown. And so this safety definition in the framework regulation in Europe actually assumes that even if you don't know exactly what the chemicals are, as long as they migrate at low levels, it is assumed that they are safe. Now, in terms of our scientific understanding, how chemicals impact human health, but also ecosystems, we cannot just by default assume that low levels automatically are safe levels. I don't want to go into this in great detail, but just pop up some keywords here. First of all, not all chemicals have thresholds. That means you cannot assume automatically that for each chemical there's a safe dose, so to say. For some types of chemical hazards, like mutagenic chemicals, carcinogenic chemicals, but also the endocrine disrupting chemicals, the chemicals that interfere with your hormone system, it's a philosophical problem in a way, actually, because you cannot test at the low doses at which these exposures occur in the human population. You can't gather empirical data to assess whether at these very low doses these chemicals really have a threshold or not. And then it becomes a philosophical question: do you assume there is a safe threshold or not? And so it depends on what values we have as a society. So do we value precaution? Then maybe you'd have to lean on the side saying there isn't actually a safe threshold. If you don't, okay, then you can say, okay, I don't know, I can't test, I will assume there is a safe threshold. So just to leave that here with you, I put a reference in the slides. You're welcome to have my slides afterwards, and I invite you to have a look at that reference where this philosophical question is discussed in more detail. Another very practical reality is that when you have food contact articles, food packaging, for example, or plastic litter lying on the beaches, you don't have one chemical that migrates at a time. Everything goes out at the same time. It's a complex chemical mixture, some known chemicals, many unknown chemicals. This is what we call the overall migrate. And we know that mixture toxicity is a very real thing. But right now, it's not being assessed for finished food contact articles. So we don't really know what is the toxicological impact of these mixtures. Maybe even if the chemicals that are migrating are below their individual effect thresholds, the whole cocktail could still have an effect. So that's kind of a black spot in our regulation right now. And then last but not least, I'm sure you've also all heard of the fragile fetus concept, that during fetal development and early life, chemicals can actually disrupt health. They can disrupt the metabolism, for example, and then the metabolism gets reprogrammed. They can interfere with the immune system, they can interfere with the nervous system, and so on. They do this at very, very low levels, and they do this during these sensitive windows of development. And so that's a whole research area in itself, the DOHA, Developmental Origins of Health and Disease. And again, I invite you to have a look at the reference that I provide here. Okay, so just to give you this information in this context, a brand new report came out yesterday, put together by the Endocrine Society, which is the largest scientific society in the world, focusing on endocrinology and all the related health impacts, human health impacts, but also obviously looking at the impacts of endocrine disrupting chemicals. And they partnered with IPEN, the NGO IPEN, and put out this Plastics, EDCs and Health report, which is not an academic publication, but put together by very well-known endocrine disruption scientists. So I recommend you to have a look at that. And then also, shameless self-promotion, I have a short essay coming out in PLOS Biology on tackling the toxics in plastic packaging. So I don't know exactly when that's going to be published, but hopefully soon. So let's turn to micro and nanoplastics. Since this is the focus of this group's work, I thought I'd just share very briefly some of the recent academic studies that came out in this area. So these are different, with different focus, looking at mechanical stress, looking at the tea bags, then the baby bottles. I'm sure many of you saw that when that came out just a couple of months ago. And then also this one here that came out in 2020 also, where researchers looked at different ways to open packaging and how that would generate microplastics. And basically the conclusion from these few studies so far is that yes, food contact plastic, food packaging seems to be a very likely and relevant source of human exposure to microplastics. So this definitely needs further looking at. Okay, so just have to check how much time I still have. What's the way forward? This may all sound very, very overwhelming to you, and you may be scratching your head and thinking, okay, so we're screwed. What can we do? I think the first thing we need to do is to acknowledge the complexity. I know that as human beings, we have the urge to do. We see a problem, we want to act on it, we want to go out there and feel like we're doing something. I think that's great, but at the same time, I also strongly think that the way you frame your problem and the level of problem understanding that you bring to the solution table will determine what solutions you focus on. And there are the quick fix solutions, which may then end up becoming tomorrow's problems or regrettable substitutions. And then there are the solutions that maybe embrace the complexity of the issue. And I think with food packaging and plastic food packaging, we just simply have to acknowledge the huge complexity that there is. Food packaging is a highly engineered product. It enables global supply chains. So when you walk into a supermarket, you have a lot of choice in terms of your food products. You can get all kinds of different sausages, vegan and chicken and pork and what you name it, whatever, but it's all in plastic, right? I think we all know that reality. So just take a quick look at the functions of food packaging. I think the sort of original first function of food packaging when it was invented back in the 19th century by Nicolas Appert was really to keep pests out, to prevent spoilage, and to enable storage, long-term storage of food. This was a disruptive invention, people today would probably call it. It made people increasingly independent of nature's kind of cycles and the seasons when food would be in abundance and then when food would be scarce. So food packaging has this huge, huge social dimension as well. And then over the years, of course, all these other aspects gained importance from, protecting the flavor, protecting the nutrients, advertising the product, conveying information to the consumer, to enabling an experience, or enabling convenience, or importantly, enable the logistics of complex global supply chains. And I look forward to the next speaker's presentation as an economist, how that plays a really huge important role for why plastic food packaging, despite it clearly being a problem in terms of environmental pollution, is just still continuing to be used worldwide. Now, the next point I want to make here is that we have to integrate the available knowledge. So we cannot focus on solutions that just address one part of the problem. And right now, people are talking about circular economy, and people are saying we have to recycle plastic, mechanical recycling, chemical recycling, reducing plastic, and so on. I just really want to stress how important it is that chemical safety has to be a fundamental part of all of those solutions. So yeah, we have to reduce resource consumption, energy use, but we cannot do that by compromising chemical safety. And I just want to show this very quickly. We have the world of the circular economy, we have the world of the food contact materials, and importantly, there's a huge disconnect between these two worlds, and it's so essential that these two worlds are brought together much more moving forward as we find solutions also in the technological space, which will lock us into certain ways of living for the next 20, 30 years or more. Just to show you a couple of examples here, this is from the European market, food contact articles that were bought in Europe that contain highly toxic brominated flame retardants, heavy metals. And here the hypothesis is that they were made from illicitly recycled electronic waste. So in electronics, you use flame retardants. The waste electronic gets repurposed into food contact articles, and then it contains these highly toxic chemicals. So this is really an example of where circular economy thinking is going the absolutely wrong way. There's a couple other studies that show that. We did a review on this if you're interested, looking also at other types of food packaging, not just plastic. And it's also an issue for reuse. I just want to make that very clear that when you reuse food contact materials, as I mentioned initially, chemicals can also be absorbed by food packaging, for example. You don't want those migrating out again when you're putting food into that container the next time, if it was a toxic chemical. So again, a great report by the NGO IPEN together with a bunch of other colleagues on plastics toxic additives and the circular economy. Okay, I see Simona's popping up, so I better wrap up. And my last point I wanted to make is, as we move forward and look for safer alternatives to single-use plastic, we absolutely have to start testing the finished products, finished plastics, finished food packaging articles. And I would argue that right now, I'm a big fan of in silico, of modeling, QSARs, and so on, but I would argue right now that we need to invest much more into actual wet lab processes, in vitro high throughput testing of the overall migrate, because right now we have all these unknown chemicals. So there's no way you can do in silico predictions for unknown chemicals. And there's a couple of studies that show people have been working on this and continue to work on it. I want to highlight these studies by Martin Wagner and his colleagues here, but also a couple of other groups. And there's many more. I just picked a few. These two here are also reviews if you want to have a look at what the thinking is. It's work in progress, but I think this is a very promising area. Another comment I want to make here is the chemical strategy for sustainability that was recently published in October by the European Commission. And the Commission will introduce or reinforce provisions to take account of the combination effects, for example, in food contact materials. So that's going to be interesting to see what the Commission comes up with. And they have a mandate from the Farm to Fork strategy also published this year to have a revision of the food contact materials regulation on the table by the end of 2022. So this is a hot topic right now. And then I was going to go through a couple of examples of what other stakeholders are doing, putting together their own lists. This industry group here, food brand owners, the Environmental Defense Fund with lists of chemicals they think shouldn't be used in food packaging. This is another resource that we just published last week on the FPF website. It's a database of the commitments that brand owners and retailers are making in terms of packaging. So both in terms of reducing waste, but also in terms of reducing hazardous chemicals. So I invite you to have a look at that. It's not ranked. It's just the information compiled. And I think I will skip this. Come to my conclusions. So chemicals matter or set low doses. It's best to avoid chemicals with certain hazard properties of high concern as mandated by the chemical strategy for sustainability. I think food contact material research is important also for plastic pollution. So this is a big resource if you're interested in the chemicals in plastic. I think this is the place to start. I think also what we've seen so far, plastic food packaging is a very likely and relevant source of human and environmental exposure to micro and nanoplastics. And we need new holistic approaches to solving plastic pollution. So with that, I want to thank the fabulous team at the Food Packaging Forum. It's a pleasure to be a member of this team. And if you want more information about our resources and our work, please have a look at our website. And I look forward to the discussion. Thank you so much.